Hello mathematicians, this is the video for the Unit 4 review sheet, and this is the first of 2 review sheets. Remember, if you feel great on the review sheet, you'll feel great on the test because they're very similar. Number 1, Tommy needs to arrive at the race by 8 a.m. She needs 25 minutes to drive, 15 minutes to eat breakfast, and 45 minutes to shower and get ready. What time does Tommy need to wake up to arrive at the race on time? So this is actually a working backward problem, and I'm going to show you 2 ways to do it. The first one is with a number line, and we'll also do a subtraction problem. So she needs to get to the race by 8 o'clock, and now we need to jump back 25 minutes and 15 minutes and 45 minutes to figure out what time she needs to wake up. So the 3 times that I'm looking at are these, and I'm going to put 2 of them together. 15 minutes plus 45 minutes, I know that that equals 1 hour. So I'm going to jump back 1 hour, which puts me at 7 o'clock in the morning. But Tommy can't wake up at 7 o'clock. She will not make it on time because I need to jump back another 25 minutes. If I jump back 25 minutes. Let's see, jumping back 30 minutes would be 6:30, but I only need to jump back 25 minutes, so it's going to be 6:35, and that's my answer. Okay? What time does she need to wake up? 6:35 a.m. Now, you have to show it in 2 ways, but I'm going to show it in 2 ways, so you know that you could do it in either way. Okay, so I'm going to start, let's see, at 8 o'clock, and I need to subtract something. I need to subtract 25 minutes, 15 minutes, and 45 minutes. I know that 15 and 45 is an hour, plus another 25 minutes, so I'm going to subtract an hour and 25 minutes. All right, with some passion in your voice, tell me what's the most popular number and the most powerful number in just math. 10. But what's the most powerful number in time? 60. That's right. So I cannot do 0 minutes minus 25 minutes. So I'm going to take an hour, and that hour is the same as 60 minutes. Now I can subtract 60 minus 25, and you might be able to do that in your head, or maybe you're going to think this, and you get 35. And then 7 minus 1 is 6. And I can see that I get the exact same answer as I did with my number line. Number 2, Mike won the first heat. Remember, a heat is like the first part of a race. If there's too many kids in the race, they'll do 10 kids in one heat, 10 kids in another, 10 kids in another, and they'll often take like the top 2 kids in each heat, and they get to run in the finals. All right, Mike won the first heat in 12 minutes, 42 seconds. Jake won the second heat in 11 minutes, 54 seconds. Who ran faster? Remember that with running, the lower time is the faster time, so Jake is the answer. But now I need to know how much faster. So I'm going to show it in 2 ways again, a number line as well as a subtraction problem. Our number line here, and I'm going to start at the lower time and jump up to the higher time. And how much I had to jump is the difference between the 2. So the lower time is Jake's time, 11 minutes, 54 seconds. And I'm going to jump up to Mike's time. You can jump in a whole bunch of different ways. But I like to jump to easy numbers. So I'm going to jump 6 seconds to start with. And the reason I'm going to jump 6 seconds is that puts me right at 12 minutes. 11:54 plus 6 seconds puts me at 11:60, or 12 minutes. And then I'm just going to jump another 42 seconds. And that puts me at Mike's time. Remember, the answer is how much we jump. So I just need to add 42 seconds plus 6 seconds, which is 48 seconds. So how much faster? 48 seconds, which is almost a whole minute. I'm going to show this problem with a subtraction problem as well. Remember, you only have to show it in one way. I'm going to take the higher number, and subtract the lower number. And you cannot subtract like normal until you've regrouped with the number 60 in mind. I cannot do 42 minus 54, so I need to take one of these minutes, and that minute is 60 seconds. This one gets a little funky. If I add 60 seconds to 42 seconds, that's 102 seconds. Now I can do 102 minus 54. And some people can do it in their head, but if you can't, you can do this. 12 minus 4 is 8. 8 minus 5 is 4. 11 minus 11 is 0. Well, looky there. 48 seconds, just like I got with my number line. So you can do it in either way, a number line, a subtraction problem. Maybe it'll depend on the situation, but either one would mathematically work. All right, number 3. Layla ran a 5K, a 15K, and a 20K. How many meters did she run in all? I know that there are 1,000 meters in a kilometer. A kilometer is pretty close to a mile, so there are 1,000 meters in a kilometer. So a 20K would be 20,000. A 15K would be 15,000. And a 5K would be 5,000. And I just need to do an addition problem. For an answer of 40,000 meters. So change everything to meters, add them together, bada bing, bada boom. Number 4, Ben drank 1,200 milliliters of water before the race, 700 milliliters of water during the race, and 3 liters of water after the race. How many milliliters did he drink in all? This is a simple addition problem, except for the fact that one of them is in liters. And we have to make it milliliters before we can add them all together. So I'm going to add 1,200 plus 700. And you better not add 3. You need to change 3 liters to milliliters. There are 1,000 milliliters, like a drop, 1,000 milliliters in a liter. So 3 liters would be 3,000 milliliters. And if you add them in a different order, because you like to put the bigger one on top, that's cool too. But we should end up with 4,900 milliliters. So on this one, change them all to milliliters and then add them up. Page 2. The planners of the race want to provide 200 grams of almonds for each runner at the end of the race. Remember, a gram is about a paper clip. So 200 paper clips, it's like a big handful. I'm trying to think that's probably a nice big handful of almonds as well. One of the packages of almonds they bought weighed 5 kilograms. Okay, so look at the table. The table shows how many kilograms, and let's first change that to how many grams. There are 1,000 grams in a kilogram. So 1 kilogram is 1,000 grams. 2 kilograms is 2,000 grams. 3 kilograms is 3,000. 4 kilograms, 4,000 grams. And 5 kilograms, 5,000 grams. And I basically want to know, if you divide by 200, what do you get? Or how many 200s fit into each of these numbers? So if you look at the first one, they did it for us. I know that there are 5 200s in 1,000. 200, 400, 600, 800, 1,000. So in each kilogram, if you divide it by 200, there are 5 200s in each kilogram. Okay? 200 plus 200 plus 200 plus 200 plus 200 is 1,000. So if I double that and have 2 kilograms, I'm going to have another 5 200s. Okay? So every kilogram is 1,000 grams. And every 1,000 grams, I can have 5 200s of that. Okay? So notice that the bottom row is going up by 5 each time. Okay? How many 200-gram servings can they get out of a 5-kilogram package of almonds? We already did all the work. Just looking at the table tells me my answer. 5 kilograms, imagine like 5 boxes of almonds. That's 5,000 grams. And if I divide that into 200-gram chunks, I can get 25 of them. So we can basically feed 25 runners. Okay? So the answer is 25. So if you fill in the table will tell you what the answer is. Okay? In a pattern. Number 6, fill in the table. They show it in numbers, they show it in words, and they show it in expanded form. So the first number, they showed us in numbers. Let's write it in words. 489,507. And I think I might have to write pretty small up here on the smartboard. Expanded form is when you write the value of each digit. So that 4 is 400,000. The 8 is 80,000. Remember, you can take the number and change everything else to a 0, and that's the value of that digit. The 9 is 9,000. 5 is 500. Remember, if there's a 0, no matter where it is, you could have a 0 in a millions place, it's still worth 0. So a 0 in the tens place is worth nothing. I'm going to skip that and go right to the 7 in the ones place. And that's our number in expanded form. The second one, they wrote it in word form, and we need to write it in the regular standard form and expanded form. I think I'm going to start with the first column. I think that'll make the expanded form easier. 314,000. Chunk it up. You know how to write 314. The word thousand is where the comma is. And you know how to write 255. Now that we have it in standard form, writing it in expanded form should be pretty easy. That 3 is in the 100,000s place, so it's worth 300,000. The 1 is in the 10,000s place, so it's worth 10,000. The 4 is in the thousands place, so it's worth 4,000. The 2 is in the hundreds place, so it's worth 200. The 5 is in the tens place, so it's worth 50. And the last 5 is in the ones place, so it's worth 5. And the last number, they show it in expanded form. We need to show it in standard form and in word form. I'm going to start with standard form. I think that will be easier. I see a 200,000. If this is helpful, sometimes kids like to put these blanks. I know that the biggest digit goes up to the 100,000s place, so now I can just fill in the blanks. I see a 2 in the 100,000s place, a 5 in the 10,000s place, an 8 in the thousands place, a 7 in the hundreds place, a 1 in the tens place, and a 6 in the ones place. 258,716. And that's how I'll write it in words. 258. I'm going to go chunk by chunk. $258,716. All right, moving on to number 7. We need to round the same number, but we're going to round it to different places each time. So the first time we're going to round it to the nearest 100. So I'm either going to keep it a 5 or bump it up to a 6. And I need to look at the digit that comes after. Good. And it's a 0. A 0 definitely tells us to. A 0 definitely tells us to. Good. So we're going to keep that 5 a 5 and make everything else a 0. All right, 507 is definitely closer to 500 than it is to 600. The second one, it's the same number, but this time we're rounding it to the nearest 1,000. So I'm going to underline the thousands place, and I'm going to look at what comes after. And it's a 5. A 5 tells us to... So I'm going to bump that 9 up to a 10, which bumps the 8 up to a 9. So it's a little bit of domino thing happening. You could think 89 bumps up to 90. So the 9 bumps up to a 10, the 8 bumps up to a 9. Or think this, 89 bumps up to 90, if that's a nice way to think about it instead. And everything after the thousands place becomes a 0. And the last one, we're now going to round to the nearest 10,000. And we're going to look at the digit that comes after. A 9 tells us to... So I'm going to bump that 8 up to a 9. Everything else becomes a 0. Just based on the numbers, rounding to the nearest 1,000 and rounding to the nearest 10,000 ended up actually giving us the same numbers just because of the numbers that were there. All right, on to page 3. Fill in the blank with the correct symbol, less than, greater than, or equal to. 43,000, 34,000. They're both in the thousands place, or the 10,000s place, I should say. So 43 is bigger than 34. The last one, 132,000, 132,000. So I'm just going to look at the last part of each number. 400 versus 40. 400 is bigger. Number 9, add the following problems. Number 10, subtract the following problems. Just make sure you check your steps. I know you all know how to add, you all know how to subtract, but it's easy to make a mistake if you're not being focused and checking what you're doing. All right, starting in the ones place, 9 plus 2. 1 plus 9 is 10, plus 2 more. For an answer of 821. A good thing to do with the video, remember, is to pause. Do it yourself, then press play. So this would be a really good section to do that part on. Starting at the ones place, 8 plus 8. And the last one, starting at the ones place. And number 10, the subtraction problems. Remember to regroup when necessary. And we're not doing time problems, so the most important and most powerful number in math is the number 10. That's right. So when we regroup, we can always break it into 10 little pieces. There are 10 ones in a 10, 10 tens in 100, 10 hundreds in 1,000, 10 thousands in a 10,000, 10 10,000s in 100,000, 10 100,000s in a million, and so on and so on. Okay, I can't do 0 minus 7. I can't take anything away from the tens place, so I'm going to take one of my hundreds and break it into 10 tens. But I still need help in my ones place, so I'm going to take one of my tens and break it into 10 ones. And as soon as I'm able to subtract, I like to. 10 minus 7 is 3. 9 minus 7 is 2. I can't do 3 minus 7, so I need to do some more regrouping. I can't take away from nothing, so I need to come all the way over to my 10,000s place and take 1, which is the same as 10,000s. Take one of those, then add 10 to my 3 that are already there. That one was a pretty challenging subtraction problem. 13 minus 7 is 6. 9 minus 7 is 2. 0 minus nothing is nothing. All right, that second one, starting in the ones place, you cannot do 1 minus 7. So I'm going to go to my tens take 1 away, break it up into 10 little pieces. Add it to the one that's already there. Kids all the time make this a 10. You need to make it an 11. If we add 10 to the one that's already there, it's 11. I like to subtract as soon as I'm able. 11 minus 7 is 4. You can't do 0 minus 3. So I'm going to take one of my hundreds, break it up into 10 little pieces, and add it to the 0 that are already there. Make it a 10. 10 minus 3 is 7. 8 minus 8, I can do it, so I don't need to do any regrouping. 8 minus 8 is 0. 3 minus 9, I can't do it, so I'm going to take one of my 10,000s, break it up into 10 little pieces, add it to the 3 that are already there. 13 minus 9 is 4. And 1 minus nothing is 1. 14,074. And the last one, starting at the ones place, you cannot do 2 minus 5. You can't take away from nothing. So I'm going to take one of my hundreds, break it up into 10 little pieces, take one of my tens, break it up into 10 little pieces, add it to the 2 that are already there. 12 minus 5 is 7, 9 minus 8 is 1. I can't do 5 minus 7, so I'm going to take one of those, break it up into 10 little pieces. I can't do 4 minus 6, so I'm going to take one of my 10,000s, break it up into 10 little pieces. All right, number 11. I can see that Alexis started to solve these problems, but we need to fill in the blanks. Notice that the first one is an addition problem. The second one is a subtraction problem. Starting at the ones place, 8 plus 4 is 12. I can see that she carried the 1. Right, the one that's in the tens place, so I need the 2 in the ones place down below. So 8 plus 4 is 12. So far, so good. And maybe this will help us visualize it here. Now let's look at this next column. 1 plus 7 is 8, plus 5 is 13. Alexis put the 3 down, and we need to carry the 1. 1 plus 0 plus 2 is 3, nothing to carry. The next column, 6 plus 5 is 11. Carry the 1, which she did. 1 plus 5 is 6, plus 3 more is 9. We're good. And the subtraction problem. Notice that you cannot do 1 minus 5. So Alexis came over and she took one of those 10s. We're going to break it into 10 little pieces and add it to the one that's already there. This and 11. 11 minus 5 is 6. And you can do 6 minus 6, which is 0, so we're good. The next column, you cannot do 3 minus 4. So she came over and took one of her thousands to make that 3 into a 13. 13 minus 4 is 9. 4 minus 4 is 0, and 4 minus 3 is 1. We're good. On to the last page. If you're feeling really good, you will feel really good on the test because the test is very similar to the review sheets. Last page, number 12. Julie and Katie were practicing for their track season. Julie ran 25,340 meters in a week, and Katie ran 24,985 meters in a week. How many meters did they run in all? When you see in all, what kind of a problem is it? Addition, yeah. When you see in all, it's an addition problem. So this is a really easy problem. All we have to do is add the two numbers together. I guess probably the biggest mistake kids might make is just writing it down wrong. So double check that you've written down the numbers correctly. Starting at the ones place, add them up. $50,325. Remember to pause this video, work on the problems, and then press play to see if you're correct. Number 13, Nate and Brittany competed in a bicycle race. Nate biked 12,725 meters, and Brittany biked 14,221 meters. How much farther did Brittany bike than Nate? How much farther is something than something else? Adding or subtracting? Subtracting. Obviously, we need to start with the bigger number, right? The bigger number needs to be on the top. Otherwise, when we subtract, we'll get a negative number, which we are not going to do. All right. So when we subtract, we start at the ones place. We cannot do 1 minus 5, so I'm going to take one of my 10s, break it up into 10 little pieces, the one that's already there, and subtract as soon as you're able to. I cannot do 1 minus 2, so I'm going to take 1 away, break it up into 10 little pieces, add it to the one that's already there. I cannot do 1 minus 7, so I'm going to take one of my thousands, break it up into 10 little pieces, add it to the one that's already there. That's a lot of 11s. And I should be good now. 3 minus 2 is 1. 1 minus 1 is nothing. 1,496. Remember that you can always, if you're not very confident with subtraction, you can always add your answer to the number that you subtract. And if it equals the number you started with, you know you subtracted correctly. All right, the last one. Using the data in the table, make a line plot. Make a line plot. Remember, a line plot is composed of x's. And then, of course, answer the questions. Okay, so let's make a line plot first. I can see that we are making a line plot for how far different frogs jumped. Frog 1, frog 2, frog 3, frog 4, frog 5, and frog 6. So let's look at how far they jumped in inches. I see a 19, a 10, a 22, a 15, a 15, and a 15. So our lowest number is 10. So I think we should start our number line at the number 10, so close to the left side. Let's do 10 inches. The biggest number looks like 22. Maybe let's go up to 30, just to make our line plot nice and easy. Just like cutting a cake, to make the pieces nice and easy, we cut it in half, then cut it in half again, then cut it in half again. So let's think halvesies. What's halfway between 10 and 30? Between 10 and 30 is 20, so half of that would be 10. 10 plus another 10 would put us at 20. Halfway between 10 and 30 is 20. Think halvesies again. Halfway between 10 and 20 is 15. Halfway between 20 and 30 is 25. So all of these marks that I've made are evenly spaced, and it's going every 5. And if I put 4 little marks in between, then each mark will be worth 1. Keep them nice and spaced out. And I'm not going to label each mark because I think that'll make my numbers too smushy. Okay, now it's time to plot those points on the line plot. Frog 1 is at 19. Frog 2 is at 10. Frog 3 is at 22. Frog 4 is at 15. 5 is at 15. And 6 is at 15. All right, here are the questions. Maximum. Don't you dare say 30. 30 is not our maximum. 30 just happens to be the biggest number on our line plot, but there's no data there. The maximum is the biggest piece of data, the largest number, which is 22. The minimum is the smallest piece of data, which does happen to be the smallest part of our number line as well, of our line plot. So 10 is our minimum. Home, home on the range, where the max and the minimum play. So the range is the difference between the biggest number and the smallest number. 22 minus 10 is 12. So the difference between the frog that jumped the farthest and the frog that jumped the shortest distance would be a whole foot, 12 inches, right? That's a big difference. Mode, most, mode, most. The mode is the number that occurs the most often, or the most frequent number, or the most popular number. It's pretty obvious in this set of data that 15 is our mode. Here are the answers. Page 1. Page 2. Page 3. Page 4. All right, kiddos, remember that the test looks just like the review sheet, so any questions that you felt a little so-so on, those are the types of questions that you should focus on. I will see you in class.